Okay, so in this video we're continuing on the transportation tableau, and in the last video we saw how to build one. So just real briefly, we have our warehouses on one side, we have our customers on the other, and inside here we put our costs inside the boxes. Here we have the total amount available to ship, and here we have our demands. And we said that if the total demand, which is 90 in this case, is equal to the total supply, which is 90 in this case, if those are equal, then we say we have a balanced transportation problem. Okay, and so what we were saying is, what happens if we don't? How are we going to build our tableau? And so here's an example. So in this example, suppose I've got two wells that supply water. Whoops, I'm getting crazy here. Two wells supplying water to three cities. A, W's, and C's again. Good. So in this first case, our wells will each supply 50 million gallons, say. And our three cities, let's say, each have a 30 million gallon demand. Okay. Well, right off the bat, you're going to see a problem, right? Because we're only supplying 100 million gallons, but we have a demand that is 90. Oh, that'll work. I think these were supposed to be 40. Okay, these are supposed to be 40. Let me change the problem to 40. Actually, you know what? Let's keep it the same. 30, 30, 30. Because we did have a problem, right? It's just a different problem than I thought. So we're supplying 100, but we only have a demand of 90. So what am I going to do with the other 10? So the way to do this in this case would be to create a dummy city. And how much water would the dummy city demand? It would take up the extra 10. And so when you're building your tableau in that case, we would have well 1, well 2, and then we would have city 1, city 2, city 3, and then we would have a dummy city, right? And then when we fill in our supplies and demands here, we have 50. Whoops, sorry, got one more column there to go. We have 50, 50, 30, 30, 30, and now we have our 10, and so now this is summing to 100, this is summing to 100, and so this is now our balanced tableau. Now what does this entry represent? That entry represents how much well 1 is not sending out, right? It's what's below the 50 million gallons. And similarly, this value right here would be the amount that well 2 has left over. So it's not getting up to its 50 million either. Okay. And so now, let's change the problem slightly. Back to what I thought it was going to be when I started. And that was, suppose we have two wells, each with 50. But now suppose we have three cities, and each with 40 demand. Now where's the problem going to be? 120. 100. 100 is not equal to 120, so that's the problem. And so no matter what happens, no matter how I distribute my 100 million gallons, there's no way I can satisfy the demand. Therefore, what we're going to do is create a dummy well. I don't need to do that, well. And how much will the dummy well pump? Well, the dummy well will pump 20 million gallons. Okay? And so now the tableau is going to look like well 1, well 2, and a dummy well. City 1, City 2, City 3. And now we would write down our tableau with an extra well, right? And now when I write down my supplies and my demands, I've got 50, 50, and 20, and then I've got 40, 40, and 40. Okay, and then I would fill in my costs. And notice that I don't have costs for these values here, right? So what would this cost represent? For example, let's put this in red, this cost right here. Well, that is the penalty for not having enough water, to City 1, right? And so similarly, this number would be the penalty for not having enough water for City 2, and similarly you could fill this in for City 3. Okay, now up here, where would these costs come from? Well, these costs, would these, I guess one way to think about it, would these costs be large, or would these costs be small, right? Because actually these costs would be small because it's not costing us to not pump water, right? And so in this case, costs might be small. But what about the penalties in the second case? Would these be big values or small values? Well, the penalties would be big. These would probably be big values, right? Because what you don't want to have to fill in these values very much, right? You want to kind of minimize the penalty overall for not matching the demand. Okay, so those are some problems, some issues we're going to run into when we start to assign numbers into each of these cells. Okay, in fact, let's just take a look at a problem, the original problem, and see, is there a way we might work out how to assign numbers to the cells? So in this case, just as a reminder, we had W1, W2, C1, C2, C3. We have 50s, 50, 50. Oops. 50 and 40, sorry. Then we had 30, 30, 30. And then we have our costs, which were 15, 10, 35, 50, 25, and 40. And let's just see if we can just reason out what a good solution might be for this problem. So just to start things off, let's just start with customer 1. Oops. Starting things off with customer 1. Let's see, it's going to cost me $15 to ship from warehouse 1. It's going to be a lot cheaper to ship from warehouse 2. So I'm going to want to maximize the amount of stuff, right, that I can ship from warehouse 2. Now, how much can I ship from warehouse 2? I've got 40 things available right now. So let's just go ahead and max it out. That would be 30. So how much do I need from warehouse 1? 0. Okay, but that only leaves me with 10 more things there in that warehouse. And so I've got I've got customer 1 all satisfied. Okay, now I go to customer 2 and I say, how do I fill in these numbers in order to fulfill customer 2's needs? Well, I see 35 versus 50. 50 is way bigger than 35, so I want to maximize the amount of stuff that I'm shipping from warehouse 1 to customer 2, and so I'm going to take this 50 and I'm going to go ahead and put all 30 to customer 2, right? And so 0 from this warehouse, and so that leaves me with 20 there. And so you can see what's happening. That forces me then to ship 20 from warehouse 1 and 10 from warehouse 2. Okay, and so what we have here is we have a solution. I wonder, is it a basic solution? Do you remember what a basic solution was? We have 6 variables, right? So the question is, how many zeros do I need in order to um, get a basic solution? I'll let you think about that, and we will pick this up in the next video. It's after 10 minutes, so I'll let you think about those problems, and we will come back with another specific example, and I'll also show you how to solve this problem in Excel. See you then.